Okay, everyone, so we are looking at qualitative chemical analysis here. So the term qualitative essentially means that you are looking for visual observations. So we're not looking at number data here. We're looking for basically visual clues that will indicate to us what the chemical analysis is of that particular solution in this case. So in general, there's two types of analysis that can exist in chemistry. We have qualitative and we have quantitative. So quantitative is where you're doing calculations or numerical measurements. So this can be temperature or concentration or density. It's where you have essentially numbers. Okay, so you're dealing with number analysis. It could be the mass, volume, boiling point, melting point, anything that has a numerical value. The qualitative analysis is essentially a way of identifying what the chemical compound is, but you're not actually calculating the quantity of it. So this might just be, okay, do I have an acid or do I have a base? And you do a test to see, maybe you take the pH of it, or you use litmus paper. If it turns red, it's an acid. If it turns blue, it's a base. So you don't have any number. I don't know what the concentration is, but I can tell if it's an acid or a base based on color change. So qualitative analysis is going to be the target for today, like what we're going to learn how to do. And quantitative analysis we'll look at more in detail in the next lesson. So there's a few ways that you can determine the qualitative analysis of a compound. Sometimes we can do that using the color of a solution. So the color of a solution can be literally just what does the solution look like. Sometimes it will naturally have a color. It can be a flame test or a gas discharge tube. Okay, but this is not a great analysis for every type of solution. So a lot of aqueous solutions are colorless, right? So they're basically transparent. If you're looking at it, it almost looks as if it's water. So especially compounds that involve group 1, group 2, or group 17 elements. So for example, chlorine ions, sodium ions, barium ions, anything from group 1, group 2, and group 17 have actually no color to them. However, when we're doing solutions that have specific elements that do have a color, it actually can be a little bit helpful. So for example, I already mentioned the colorless ones, but here are examples of some ions that have a color to it. So let's say we were looking at a blue solution. The blue color might be because we have chromium positive 2 ions. So you can kind of see what kind of solution you have based on the color that it is. Now the problem with this, and you may have already noticed this, is sometimes you can have multiple compounds or multiple ions that will give off the exact same color. So for example, chromium positive 2 and copper positive 2 are both blue. So if I have a blue solution and I said to you, okay, tell me what is inside of this solution, you wouldn't be able to tell, okay, well, which one is this? Because they're both the same color. Same thing with green. Green, we have 3 different solutions. It could be chromium positive 3, copper positive 1, or nickel positive 2. It's not definitive. So sometimes you can use the solution color as a helper, but you're not going to be able to be very specific in terms of what it is. And what if it's colorless? If it's a colorless solution, it could really have a whole bunch of different ions in it. So this is a good starting point, but it's not really going to be our decision maker. Okay. Another type of test that we can do is a flame test. So sometimes when you put a solution in the presence of heat, okay, very hot temperatures, a specific color can be given off. So depending on again, which ion it is, will give off a different color. So, pardon me, I thought I had the next slide with colors. Let me get you a chart. It's actually on your data table. If you take a look at your data table, I'll pull it up and I'll show you where you can access this information. Okay, so here is our data sheet. Let's open this up. So you'll notice that we have, actually it's on the back side of your data sheet, the second page, we have ion colors. So notice actually it's the same chart that I had up on the slide where we looked at different solution colors. And there's also the flame test results from different ions. So I will tell you that there are more ions that actually give a color than the ones that have a flame test color, but it can sometimes be useful as maybe a first kind of preliminary assumption as to what something is. But the same kind of problem is going to happen here. So for example, let's say I had a yellow solution. You'll notice I'm going to put a video that you can watch that will show you an example of a flame test. Sometimes it's very hard to distinguish, okay, well, is it a yellow or is it kind of a yellowish red or is it a yellowish green? The colors are not very distinctive. So it's not like, oh, that's for sure a yellow red. What if it kind of looks orangey? Yellow and red together kind of, make up orange. So like, who knows if you're going to be able to tell that? Same thing with green. Is it yellow green or is it green green or is it a whitish green? So, I mean, it's good to kind of have a first guess as to what something could be, but this is not, I wouldn't bet my life on it. So if you had to for sure guess what an ion was that was in a solution, both of these would not be a great way of knowing what is inside of your solution. They're kind of just, so again, we're using colors, so it's a qualitative analysis, right? So yes, you can do this, but it's not really definitive. So what is definitive? What can we use? So we have something called sequential qualitative chemical analysis. So this is essentially where we're going to do a step-by-step process that we can for sure identify what is in our solutions. Now we're going to be creating what are called flow charts. So this sequential analysis is essentially creating a flow chart for analysis. So in addition to looking at colors and flame tests, we can be very specific though if we actually create this, pardon me, this type of analysis. We can be more specific and correct about our predictions. So what we're going to use to help us here is our knowledge about precipitates and how it works on the solubility table. So actually going back to this, right? So we're going to use our friend, the solubility table here, to help us actually create these qualitative sequential analysis flow charts, which right now doesn't make a whole lot of sense because we have to still, of course, go through it. Okay, so what is the purpose of this? So the purpose of any analysis for qualitative reasoning is we're trying to determine an unknown. So you're given a sample and you're asked to say, okay, well, what is the compound that this solution is made up of? So we can try the color, look at the color, do a flame test, but we want to know for sure what the solution is. So how we're going to do that is use our solubility table, and we're going to do a double displacement reaction where we have one solution that we don't know and one that we do know. So we're going to have, let's say you have AB plus CD. So one of them we'll know, and one of them is the one we're trying to find out what it is. So then we're going to check the solubility table, and if we create a precipitate, we can start to look to see, okay, well, what could have made a precipitate with that particular ion or compound? So this is called a qualitative chemical analysis. So we're going to go through different steps of how to go about doing this. Okay, so suppose you were given a solution that might contain either lead positive 2 ions or strontium ions, or both or neither. Okay, so all of these situations are going to be about the same. You're going to be told options about what could be in your solution. So what does this mean? Oops. Sorry about that. Get this connected. So we could have one out of the two. We might have both of them, or we might have none of them. So it's kind of tricky here. We want to basically test to see what do we actually have in our solution. So let's take a look. So here are the scenarios. So scenario 1, we have none of the ions. So no lead and no strontium. Okay, so remember, what are we thinking about here? You're given an unknown solution and you're told you could have lead, you could have strontium, you could have both, or you could have none. So scenario 1, we have nothing in there. Scenario number 2, we have lead ions, but no strontium. Okay. Scenario number 3, we can have strontium ions, but no lead. And then this fourth scenario, let's scroll down. The fourth scenario could be, I have both. So scenario number 4, both lead and strontium are there. Okay, so we either have none of them, one and not the other, or both of them. So we have to figure out, how are we going to prove this? How are we going to prove what scenario we are actually coming into? So this is where we're going to create a flow chart. Okay, so this is actually much easier if I explain this, doing it together with you from scratch. Okay, so what we want to do using the solubility table is we want to pick something that will precipitate with one of the ions that we're trying to investigate. Okay, so we want something that will make a precipitate with lead or with strontium, but only one at a time. So we want to pick an ion that will precipitate, let's say, only lead. So for example, do you see how sulfate has lead and strontium there? This one will precipitate with both ions. We want to test only one of the two possibilities. So actually what we can do, we have a couple of options. We can use chlorine, bromine, or iodine, because if you'll notice, lead will precipitate. Or we could also use hydroxide. Hydroxide is aqueous with strontium, but it will precipitate with lead, +2. So anytime, I'll kind of start off by saying this, anytime you are doing these sequential flowcharts, you could have more than one correct method of doing this. So right now, I could pick one of these ions to do lead, or I can choose hydroxide to test for lead. Okay, but I can't pick sulfate because both of them are here. I can't pick carbonate, for example, because both of them are here. You want it so that you're isolating for only one of the ions. Okay, so let's go back here. So let's assume we're going to create our flow chart. I'll show you the setup of this. So up at the top, okay, so up at the top, you're going to put what your what your ion possibilities are. Okay. What we're then going to do is we're going to write in the ion we're going to use to test. So for example, I can add chlorine ions. Okay, I'll continue this in our next part.